Okay guys, welcome to 2.6b. We are going to be analyzing rational functions this time. Pretty much I'm just going to do 3 examples and show you 3 different types you're going to see and have to analyze. This is where you're going to have to be able to graph these without using the handy dandy calculator, okay? So, here's what you got to think about. I'm going to put each of these in Mr. Terwilliger definitions, but they're still going to be long, guys. So no complaining, no complaining. Okay, you can complain, just do it before you get to my class, please. Please. Okay, so remember, you have your numerator over your denominator, right? So, if you're looking for your horizontal asymptote, if your degree of your numerator is less than, okay, the degree of denominator. So if the top's degree is bigger than the bottom, your asymptote is y equals 0 is your horizontal asymptote. Okay? So, for example, if you have x plus 1 over x squared minus 2. The degree of your top is 1, degree of the bottom is 2, your horizontal asymptote is y equals 0. Okay? What the next one says, if the degree of your numerator equals degree of denominator, well then y equals, well, it equals your the division of your leading coefficients. So you take your leading coefficients and divide over each other. So in this one they said a of n over b of m. I'll put an example, it's the best way to see it. So if you had 2x squared plus x minus 1 over 3x squared, your degree of your top is 2, your degree of your bottom is 2, so they're equal. So y equals 2/3. You grab these leading coefficients is your horizontal asymptote. Okay? And there's one more point to this one. Don't worry about the bottom part. If your degree, I gotta change color to be fancy. If your degree of numerator is greater than your degree of denominator, then your end behavior you don't have an asymptote, so you have no horizontal asymptote, but your end behavior is whatever the division is, whatever if you actually divide them out is. Okay, and we'll see one like that, but you can't, there's no horizontal asymptote, so don't worry about that. Okay? Okay? There's some other things we need to find too. Again, I'll do the noteworthy Mr. T version. Is, by the way, if you didn't write down this stuff before, you're being silly. Vertical asymptotes. That is, you set your numerator, you set your denominator equal to 0. You set the bottom equal to 0. X-intercepts, you set your numerator equal to 0. That's the top. You set the top equal to 0. And for Y-intercepts, plug 0 in for x. Okay, so that's what we're going to be doing. We're going to be analyzing these functions. We're going to be finding the asymptotes, the vertical, horizontal, and we're going to be finding our x-intercepts and y-intercepts. Because when you have all that, you can graph these things. And you don't even need a calculator. Let's do our 3 examples. Here's the first one. And we're just going to find the asymptotes, so I'm going to do x and y-intercepts as well. Okay, let's go and write that down. I'll give you a second. Okay, first things first, for that horizontal asymptote, your so my degree of my top, my degree is what? There's 1, 2, x is x times x is x squared. So my degree is going to be 2. My degree of my bottom, x times x is x squared, is 2. Now, if our degrees are equal, you take your leading coefficients, and that becomes your horizontal asymptote. So we look at this, I can throw a 1 in here because that's what's actually there. So my horizontal asymptote is just going to be 2 for 1, or y equals 2. Okay. Number 2. Now my vertical asymptotes, my va, what I do is I take a look at my denominator. And I set that equal, I set that equal to 0, right? So my vertical asymptotes are x equals -1 and x equals -5. -1's coming from over here. -5's coming from over here. Okay. Third thing we want to find are these zeros, also known as your x-intercepts, right? Also known as the roots of your function. Okay. So now what I do is I take my numerator, the top, and I set that equal to 0. So my x-intercepts are at x equals -3 and 3, right? So my x-intercepts are -3, 0, 3, 0. Okay, so bad. So far, so not so bad. Now, don't yell at me on your homework. You will have to factor the top and bottom. That is my robot one. Okay, now for a y-intercept, this one's going to actually be the most math. We have to plug 0 in. So we go 2 times 0 plus 3 times 0 minus 3 all over 0 plus 1, 0 plus 5. So we get 2 times 3 times -3, 3 all over 1 times 5, which is going to be -18 over 5. Okay, now that's our x, so we put, I'm sorry, so that is our y, so it's 0, comma that, right? That's our y-intercept is 0, comma -18 over 5. Or you want to simplify it, was that 3.6, -3.6. Doesn't really make a difference. Okay? Okay. Not too bad, not too bad. Alright, next one. Oh no, my cheat sheet. Here you are. Okay. Next one we're going to look at is this beast. Same type of problem. We're doing the same exact thing we did before, but it's going to be a different case. Okay, So first thing we look at, the degree of my top is 1, right? It's only x to the first. My degree of my bottom, my denominator, is x times x. X squared is 2. So if my degree of my numerator is greater, or I'm sorry, is less than the degree of my numerator, if you look back in your notes, we know that our horizontal asymptote, our has to be y equals 0. Okay, and that's back in our notes. If your degree of your top is smaller than the degree of your bottom, your horizontal asymptote is 0. So done. Now vertical asymptote, remember we set the bottom equals 0. So our vertical asymptotes are x equals 2 and negative 3. Okay. Now for our x-intercepts, also known as solutions, also known as roots, also known as your missing one here, zeros of your function. Thank you. We set the top, our denominator, equal to 0. Okay, the x minus 1. So x equals 1 is our x-intercept. So that is the point 1, 0. And last but not least, our y-intercept. And we are going to graph this one, guys. Our y-intercept is, well, we plug in 0 for our function. And we get negative 1 over negative 6, which is 1/6. So if I go to graph this guy, I'm going to have a horizontal asymptote at y equals 0. I'm going to have a vertical asymptote at 2 and negative 3. Okay. I have an x-intercept at 1, 0. And I have a y-intercept of, oops, I didn't finish this guy out, 0, 1, 6. Okay. And guys, this one is kind of funky looking, so I probably would let you use your calculator to actually graph it. Okay, so don't, you're probably like, Mr. Twilliger, this is ridiculous. And it is a little bit, but here you go. But I'm going to look for this work to make sure you know how to find these things, okay? Okay, I got one more thing to look at. We got a bonus one. Let's just look at the function x squared plus 6x plus 5 over x plus 1. And look at its end behavior. So, the degree of my top, that's also known, that's my horizontal asymptote. The degree of my top is 2. Degree of my bottom is 1. So if my numerator's degree is greater than my denominator's degree, I don't have a horizontal asymptote. So no, there's none of those. No laughing, no huh. So to find end behavior, what you do is you divide it out. So negative 1 comes from that x plus 1. This is the top part, right? Oops. 1, 6, 5. So you get 1, negative 1 is 5, negative 5 is 0. Ah, that worked out nicely. So we end up getting x plus 5. What that means is when you look at this graph, which does have a vertical asymptote at negative 1, right? When you look at this graph, what it looks like, this, and then it goes this. It's actually going to go through that 5. But it falls along the line x plus 5. Its end behavior is when you actually divide out the function what it is, okay? So just keep that in mind that those exist. If you want to see me do another example like this one, I will, but I'm not going to ask you about its end behavior because I'm just going to be looking at asymptotes for now. But I might get tricky and throw one in your homework just see how you guys do, okay? Alright, peace.